Hello, this is Garrett Keane and I'm going to run through the pseudocode for the VBA program to calculate the function y is equal to exponential x using the different terms of the MacLaurin series for this function. If you remember from your maths from the first semester, the expanded MacLaurin series for the function y is equal to exponential x is given as 1 plus x squared over 2 factorial plus x cubed over 3 factorial and so on. The general term where you have the value k is x to the power of k over k factorial, and it runs all the way up to x to the power of n divided by n factorial. You can express this in a neater format by saying y is equal to exponential x is equal to the summation from k is equal to 0 up to k is equal to n of this general term x to the power of k over k factorial. What you can basically do then is you can use a loop in VBA to run through this to calculate each term using this formula here and add it on to a running total each time. So you basically can use a loop in Visual Basic to implement a summation of a series like as shown here. Just as a pointer, we're starting from k is equal to 0, so if you substitute 0 in for k, x to the power of 0 divided by 0 factorial 0 factorial is equal to 1, and any function to the power of 0 is also equal to 1, so we get the 1 here, and that corresponds to the 1 shown up here. If we then substitute in the second value k equal to 1, x to the power of 1 divided by 1 factorial is x also, and that gives us the second term. The rest of them are kind of intuitive from just looking at them because they match up with the term here, with the function here. If I run down to the pseudocode, as we said before, is just basically a solution for the program, but not actually using proper VBA code. It sets out the steps that are needed to actually implement the program to execute the MacLaurin series. So what this program will do is it'll ask the user to input the value of x, because you're getting an exponential of x, you're calculating the exponential of x, and n, which is the number of terms of the series to be calculated. The program will then iterate through a loop n times to calculate each term of the series, which is then added to a running total. For each iteration, the program will add the new term and the running total to a string variable, which is output to a text box after the loop is completed. So that's kind of a summary of what the program is going to do. We declare these variables. K is an integer loop counter to specify which term is calculated. So the k will tell you, it's a loop variable. It tells you at what point what the value of k is on the loop, but also it's the k that you see up here. It corresponds to the k in that summation function. So also x is, the user has to put in a value for x, so we need a variable for that, and that variable should be a double. I should specify it here as a double variable to store the value of x to be used in the function. Also, we need a double to store the value of the term as it's calculated, because more than likely it won't be a whole number. The single variable is used to store each new term as it's calculated. It's immediately added to running total exponential x and is output to the text box if required. So as you run through the loop, you don't have a separate variable for each new term. You're just going to use a single variable to store it, and as you go on to the next step of the loop, the previous value is going to be lost. So that's why it's essential to add it straight on to the running total and also output it if you need it at that stage. Exponential x is the double to store the result. It's also basically the running total. And n is the integer to store the number of terms of the series to be calculated. The user inputs this and you have to read it in. Output string is the string to store the list of terms and the running total exponential x. Then you get into the program itself. The first step is to initialize exponential x is equal to 1 for the first term, which corresponds to when k is equal to 0. So basically that's that value up there. That means when you actually run the summation, you don't start at 0 because you've already set the initial value to 1. So we'll start at k is where k is equal to 1. So for k is equal to 1 to n, each time within that loop we have for and the next k down here, so we're going to repeat these steps n times. So say the user puts in 10 for n, we're going to run through this loop 10 times. The first step is to calculate within the loop is to calculate the term for the current value of k. So we calculate term is equal to x to the power of x to the power of k divided by k factorial. Then, having calculated the term, we add the term to a running total exponential x. And because we want to have a list of all the terms to examine when it actually converges, we output the term and the running total to a new line on the output string. So we run through this loop, and as we run through it, the value of exponential x is getting bigger each time because you're adding each new term to it. And also the string, the output string, is getting bigger because you have a new row for each value of k. When the loop is finished, you then display the output string on the text box, and that's the last step in the program. Okay, thank you very much for listening, and the next video will be actually show you how to code it in VBA.